let's try to solve another Leetcode problem. 1792 maximum average pass ratio. So for this problem, we are giving a classes array. So inside the classes array, it's gonna have two variables. So the first one gonna be the pass, and the second one gonna be the total number of students. So let me just choose the first example. So we're gonna have 1 and 2, yeah. And now we're gonna have our pass ratio. So it's gonna be the pass divided by the total. So for this one, it's gonna be 0.5, yeah. Let me just use 1 divided by 2 like this way. And for the second one, we're gonna have 3 and 5, yeah. So the pass ratio gonna be 3 divided by 5. And for the last one, it's gonna be 2 and 2. And the ratio gonna be 2 divided by 2, yeah. Now we have this kind of a ratio. So if there's no extra students, so we just need to return the total sum of these values divided by 3. So this one plus this one plus this one, yeah, divided by 3. So this is going to be the final result. But we're going to have extra students. So the meaning of the extra students is that for each one of the students, definitely this student can pass. Yeah. So for example, if here we're going to use extra student, so it's going to become 2 divided by 3. Yeah. So if we assign another extra student to the first class, to this class, so it's going to be 3 divided by 4. Now we used up all the extra students, and then we're going to use 3 divided by 4 plus 3 divided by 5 plus 2 divided by 2, and the final result is going to be, yeah, this one, which is going to be the maximum value. Yeah. So but how can we find this maximum value? So actually we are giving this kind of a formula. Yeah. So the formula is x divided by y. So if we add one more student, so what's going to happen? It's going to be x, yeah, let me put it here. So x plus 1 divided, so this means from x plus 1 divided by y plus 1 and minus x divided by y. So this means from here, basically I can get the maximum difference value, yeah. And according to all those figures, basically I can find the maximum difference value. How can I find it in log n time? Basically we're going to use the priority queue. So we're going to use our max heap, yeah. So for each of the time, we're going to use this formula, and we're going to put it inside of the max heap, and this is our added ratio, or we're going to call it added ratio, or we can directly call it a ratio difference. Basically we want to have the maximum ratio difference for each of the time. So this time we consumed one extra student, and for the next time we're going to consume another extra student, yeah. And where we're going to put, basically it is decided by this formula, x plus 1 divided by y plus 1 minus x plus y. Maybe let's just use an example. Maybe, so this is 1 divided by 2 from the beginning. So let's just check that. So this is going to be x plus 1, y plus 1. It's going to be 2 divided by 3 minus 1 divided by 2. So it's going to be 1 divided by 6. Yeah. Now let's just try another value. So we're going to choose 3 divided by 5. Yeah. So it's going to be 4 divided by 6 minus 3 divided by 5. So what's going to be the final result? So this is going to be 2 divided by 3 minus 3 divided by 5. So it's going to be 15. 1 divided by 15. Yeah. So which difference is bigger? Of course, 1 divided by 6 is bigger. So this means basically we're going to choose this one. Yeah. According to the formula, basically we can find the maximum value, and we're going to plus the maximum value to the final result, and then we're going to use the final result divided by n going to be length of the classes array. So this is going to be the final answer. Yeah, I think it's going to be much clearer if we know this kind of a formula. Basically we know how to solve the problem. Yeah. So let me just prepare a priority queue, and let me just check the classes. So for yeah, let's just use the pass and the total inside of the classes. So we're going to use heap push. So we're gonna put it into the priority queue. So the first value gonna be x here, which gonna be, yeah, let me just use x and y. Maybe this is easier. Yeah, so let's just use x and y. So here gonna be x, yeah, what, there are so many processes I cannot find which one. So now let's just prepare the value. So here gonna be x and y, and here, yeah, so what did I do? So yeah, so the here gonna be x plus 1 divided by y plus 1 and x and y. But I need to give a negative value because basically this is a max heap. Yeah, so this is going to be the first step. Now let's just prepare the result. It's going to be sum of the x divided by y. So for x, y inside the classes. Yeah. Now we get the initial result, but we need to use the actual students. So how can we use that? Let's just use a for loop. So for anything in range with actual students, first of all, we're gonna pop it out. Yeah. Let's just pop out the ratio x and y gonna equal to heap pop, which is gonna be this priority queue. Yeah. And we're gonna update it to the result. So the result is gonna plus this ratio. So this is for the actual, if the actual students equal to 1, it is okay. Yeah. So we just finished our algorithm. So finally we just need to return the result divided by the length of the classes. Yeah. But we're gonna have actual students. It's gonna be more than 1. So what happens for more than 1? Basically we need to use a heap push and the priority queue, and here inside we're gonna push this value. Here we just popped out this value. Now we want to push it inside, but before we push it inside, basically this means for this student, because I've already used this ratio. Yeah, now I need to update this student. So this means the class and the total gonna be updated to class plus 1 and the total y plus 1. Yeah. Now I just need to update the difference. So I want to put this one, it's gonna be the same inside of the priority queue. Let me just copy and paste. Yeah. So here the first one gonna still be the same. So for the next possible, ratio, so I'm gonna update it to minus x plus 1 divided by y plus 1, and the next path and ratio is gonna be x and y, because here it has already been updated. Yeah. So this is exactly what we are doing for the problem. Yeah. So let me just use an example maybe. So for the first time, maybe I find 1 to 2 is better. Yeah, because I find 2 divided by 3 minus 1 divided by 2, I find this is going to be the biggest value. Yeah. So now I just get this ratio. I don't know what's the result, but you can calculate it. The result is basically going to be this one. Yeah. So I get the ratio and get this x and y. Yeah, this xy is 1 to 2. But now I'm gonna use this 2 and 3. I'm gonna update it to the next one. Maybe 3 divided by 4 minus 2 divided by 3 is better than all others. Yeah. So this is why I'm gonna update this x and y equal to x plus 1 and y plus 1. And then I'm gonna use the same formula again, because I wanted to try to check the next. Maybe this one gonna be a bigger value. So this is why I put it into the priority queue. Yeah. And we need to be careful with this ratio because this is a max heap. Yeah. So basically this ratio gonna have is a negative value. So we're gonna give another negative value. So this means the ratio gonna be a positive value. Yeah. Now I think everything should be okay. Let me just run it. It didn't work. It must be some mistake. Yeah, because I forgot to minus the value. So it's going to be minus x divided by y. And here gonna be the parentheses, and then I'm gonna give a negative value. Let me just copy it from here to here. Yeah, because my formula is not right. So now the formula should be right. Basically, it is this value minus this value, x divided by y, and for the total result, I'm gonna give a negative value. Yeah. Now let me just run it. Now as you can see, it works. Now let me submit it to check if it can pass. Now as you can see, it passed for all testing cases, and it's pretty fast. So the time complexity is going to be n log n. N going to be the number of actual students, and another n is going to be the length of the priority queue. So it's going to be length of the classes. So it's going to be 10 to the power 5 times log 10 to the power 5. So this is why it is n log n time. Thank you for watching. See you next time.